How do you move your data from your on-prem warehouses to cloud? Okay, that's one of the key use cases that you will come across while working on cloud as a data architect or a solution designer. Welcome to this session today, and we are going to talk about exactly this topic. We'll look at the different design considerations and the strategy to migrate your data from an on-prem database system to cloud. And we'll focus mainly on the warehouses, not on the OLTP, since this is mainly a lecture series on data analytics part. We'll look at some of the warehouses movement to cloud. So what are the different warehouses from where you can move your data to cloud, right? So you'll have to build a data pipeline to extract data from this on-prem warehouses to cloud. Now it can be any of um, the normal warehouses like Teradata or Netezza, or it can be sometimes because some customers may have built a warehousing kind of a system or Postgres on MySQL, but the most common are the Oracle Exadata, Teradata, Netezza, and then you have to move this data from these systems which are on-prem to your cloud platforms like AWS, GCP, or Azure. And we'll only talk about this data movement to data lake as of now. We won't talk about movement of this data from your data lake to warehouse. So today's lecture will be mainly about moving your data from your on-prem databases to the cloud storages, the data lakes on the cloud storages or the object storages. So when it comes to AWS, we'll look at how do you move your data from, let's say, a Teradata system to your S3. So what are the different key considerations, right? So when you're moving this data, you will have to do it right table by table basis. You will have to first analyze, understand what the data is present in these tables. So there are multiple key considerations, right? So let's say you have a table named customer and you want to move this data to S3. So first you will have to understand what kind of a data that table holds. Is it a complete snapshot data that you will have to move, or can you identify an incremental data? So what is an incremental data? Let's say you have migrated the whole data on day zero. Like let's say the customer table had 1 GB of data. Okay, that's a very small amount that I'm talking about, just for example. Okay, it has a 1 GB of data. You have moved it to your S3. The next day again you have to do this migration. So does that table hold that capability to identify the incremental data, so that you can only pull the incremental data, right? And what are the attributes for identifying that? So let's say they have a start date and end date, or these kind of an audit columns. If these are present, then you can pull the increment data based on that. But if these columns are not present, then daily you will have to pull the snapshot data. So that's the first thing you will have to look at. Some of these systems may have an inbuilt CDC capture feature also. Like I've seen some of the systems like SQL Server based databases where you have enabled the CDC capture feature. What does that do in SQL Server? It creates another table with the name as underscore CDC. So the main table and the underscore CDC save table. So there would be a customer table and there would be a customer underscore CDC table. You can use this table to build the incremental data or to extract the incremental data. So have a look at the source system. It's very important to understand the source system, the database and the tables, and what kind of a data they hold. And based on that, you can have your strategy to pull the data. So if this incremental data can be identified, then always go for that. You don't want to pull the whole data on daily basis. If at all it's not there, then you will have to pull the complete snapshot. Then the next is, what is the extract frequency that you want? Do you want it as an end of the day process? You want it as a micro batches? Would it be a real time kind of a thing? So look at that. So most of the warehousing systems, in older days it was an end of the day process, but now with the technology has become so advanced, even the real time has there has been a support for real time systems. So look at that, whether you want to do it on that basis. So because the architecture would be different for real time and end of a day process or a micro batches system. So if it's an end of a day or a micro batches, you can still have your jobs running at some fixed frequency to extract the data. But if it's a real time system, you will have to build something else for that. Maybe you will have to build something within your on-prem databases so that it can start streaming the data as messages, which you can then consume on your cloud platforms. The next is look at the connectivity details also. Like if you're using AWS, see if direct connect is available, because that would help to get the data faster, right? If there is an already a channel with this direct connect available, always use that, because see when you're trying to get your databases, the warehouses data into cloud, we are talking about huge volumes of data. There might be tables which are like 1 to 5 TB also in size. The overall data that you want to migrate would be of maybe hundreds of TBs or even in petabytes, right? So you'll have to see what is the best way to do that. And if you have decided on moving this data using some tools, okay, then you will have to look at things like direct connect and all. How it helps is, because there is a direct connectivity between your data center and your cloud, it will help to move your data faster and quicker. Okay. If this is not the case, then you can go for the options like snowball, right? If it is in AWS, and there are similar offerings with Azure and GCP. But yeah, for this lecture, let's say we want to move it using some tools, and we want to move the data from your on-prem to cloud. So always look for direct connect option. And now one more hint or one more clue I would give you, one more tip that I would like to give here is, if you're moving this data to S3 and using direct connect, always look at what is the endpoints, S3 endpoints that you are using, right? If it's a uh, I think the interface endpoint is what would be supported here. So look for that. If you don't use that, again the data would flow through internet. So that's an important part to look at it. Ensure that you are, if direct connect is available, you use that, use the S3 interface endpoint, so that the data flows within this connectivity itself and not through internet, because then that would be much slower, and you don't want this system, this extraction to be slower, because we are talking about huge volume of data. The next is obviously the data volumes per table. You will have to categorize your larger tables, smaller tables, really large tables, because then you will have to build a strategy, which we'll see in the next slide. But ensure that you have this kind of a bifurcation of your table based on the volumes. So smaller volumes would be anything between up to 500 GB, I would suggest, or even up to 1 TB. Anything anything up to 500 GB, you can say smaller volume. Anything from 500 GB to 1 TB, you can consider as a medium tables, and tables which are really big, like more than 1 TB, you can consider as a large tables. Again, based on what is the priority as well, you'll have to decide on the strategy for this. And the last is, look at from where you are going to pull this data, whether there is a separate read only DB at the source side. Many of the systems would give you that kind of a connectivity. Ensure that you are not hitting the actual database, because if that is the case, you will have to look at the downtime and all the other things. See, when you are trying to connect to this database, pull the data, they are going to utilize a lot of resources on the source side. And if the same system is used by the other systems on the on-prem side, or the customers to fetch their data, then it's going to slow down the system. So it is better to have a separate DB if available. If not, then you can always go for the primary database itself. So migration strategy, right? How do you have a strategy to pull this data? You can, like we spoke about the larger table, smaller table. So you'll have to define this based on the larger table. So let's say you have two categories. Let's say you have the larger tables and you have the smaller or the medium sized tables. So whatever strategy you are using, so smaller tables may not apply to the larger tables. So how do you move your larger tables? Right? So let's say you have a 2 TB table. You cannot just move that data on a single go, right? You will have to do it on block by block basis or chunk by chunk basis. How do you do that? So either you can do a partition based extraction. Let's say you are using something like an Oracle Exadata, and they have a partitions on a monthly basis. So see if you can just move your data on the monthly basis. Now you will have to write a custom code for that, obviously, to go through particular partition, move that data. So see whether it can be done by partitions. If there are no partitions, can you use something by based on the primary key columns, right? So let's say you want to pull just the first 10,000 records. So can you write a custom code to pull that data. So any approach, that is going to help you for this kind of a parallel processing, that will help. By what do you mean by parallel processing here? You have to open up multiple threads to do the data extraction. Okay, you cannot just have a single JDBC connection and moving all that 2 TB of data to your S3. That's not going to work. You'll have to use multiple parallel threads. Now, how do you do that? If you're using Spark, look at various options which spark.read format gives you for a JDBC kind of a connection. There are options like partitions, I believe, and you can look at the options like DB table. How do you can have multiple JDBC connections to connect to your database and then pull the data. The main thing is, if you're using Spark with, let's say, how many, some 12 executor, 15 executors, the main thing is you should have equal amount of JDBC connections, so that all the executors are have that workload distribution on them, and then you will have to monitor it whether they are doing that extraction properly or not. For smaller tables, it can be different. um, you can go for a complete extract. That's not complex extract, sorry, it's a complete extract. You can go for a complete extract where you don't have to really worry about partitions and all. You just take the table and move it as it is, right, like a snapshot data. Because the smaller tables like category tables, country code tables, right, these are very small amount of data, maybe less than a GB also. You can just move it as it is. And also think about the tools you want to use. Spark can be an overkill in this case. You can simply extract the data and just move it. Now, while we talk about the strategy and all, what tools you use is also very important, and there are various tools available. In today's topic, we are not going to focus on any particular tool, but some of the tools are the data migration services provided by every cloud provider. You can use that. If you're into AWS, you can definitely check DMS. Only thing is, I think DMS needs a read access on the change data capture side of the databases, on the source databases. Some of the warehousing systems may not allow that because it slows down the process at the source end. So have a look at that. And then, but there are other tools like Spark, Glue, EMR, or even Databricks, right? Databricks is gaining a lot of attention these days. You can definitely check it out because it can help you in writing Spark code very quickly. Still the Spark connector can be used to move this data. If you're into AWS, you can either look for a serverless kind of a service like Glue. If you want a more control service, you can go for EMR. But any of these services will help you to migrate the data. But the main thing is your strategy. What is your plan? How do you migrate bigger tables? How do you migrate smaller tables? What is the downtime that you will have to see? So as we were talking about, all these things, the SLAs is very important. You need to have your SLAs for the extraction batch completion. Let's say you are migrating from a source system and they don't have a separate read-only database. So you are extracting the data from the actual main source. So it will slow down the process. So look at the off-peak hours, maybe the night time. Generally, a night time when the users are not logged in, or even a weekend, right? Let's say a Sunday night, a lot of migrations to happen on the Sunday night between 2 a.m. to morning 6 a.m. And what is the extraction window? Let's say it's about just 4 hours. So you will have to fit all your data extraction within those 4 hours. So you have to look at number of tables, the complexity, the size of the tables, and then at the SLA for this batch completion. Then allocate resources as per the volumes, right? So you have a very big table of 2 TB. See how much Spark resources you want to assign to that. If you're using Glue, see how many DPUs you are assigning that, how many worker nodes you are assigning to that. For smaller tables, keep it less. For bigger tables, keep it more. So this also becomes a part of your strategy, right? When you're analyzing the tables, that time itself you allocate the resources and keep it dynamic. Don't hard code it. Your code should be such that you have it all dynamically assigned. Let's say you are using Airflow for this, all this triggering, and from Airflow you are passing this allocation. So you are using some other orchestration tools. Let's say you are into the the Hadoop world, and from Uzi you are doing this orchestration. So just look at what you are doing. Maybe in the Hadoop world you use scoop for that, so you have the number of, I think, mappers. You have an option called -m, where you give the number of parallel connections, and that may go through Uzi. So look at the number of tables, and there you give these things. Though that was mainly from Hadoop perspective, it was not for cloud. Now create a blocks or groups. Okay, when you are doing this implementation, create a blocks or groups uh, of the tables. Like you have small one block of smaller all the smaller tables. You have another block for medium table, right? Another block for large table. So like this, you will have to divide your tables into various groups or blocks, and then you will have to run them in parallel. Okay, so let's say in group A, I have 6 smaller tables, so this will run one after the other. Okay, at the same time, I have another group where we have medium tables, so medium table 1 and 2 will run one after the other, but the group A and B and C will run in parallel. Okay, something like this you will have to come up. Now how do you come up with this? Based on the obviously the table volume and the very first pointer, the SLA for extraction. Let's say you want to complete all this thing right in 1 hour. Okay, you want to complete all this thing in 1 hour, so you will have to come up with a strategy based on how much time this may take. Okay, so you have a group A, B, C, and D, so all these are running in parallel. Okay, in parallel, but within that group the tables are running one after the other. So you have this extraction batches running one after the other as well as at the same time. Okay, and how do you align this? Based on how much time it is taking. So this is just for representation purpose, friends. You will have to go through and understand how much time each and every table is taking, and then create this blocks, and then create the whole migration strategy for this. And this is not something you'll have to do just one time. You'll have to keep on doing this. Migrations keep on happening, so have a proper strategy, document it really well, document all your findings. Let's say a table of 500 GB, how much time it takes, a table of 1 TB, how much time it takes, with what resources. You have to document all these things. You will have to maintain a lot of Excel sheets or any other system, right? If you're maintaining and reading some of your documentation tool, maintain all these things, because you'll need all these things. And once the migration is done, then the data reconciliation comes in. Maybe we'll have a separate lecture on that, how do you do the reconciliation. But yeah, but this is just a very high level strategy. Again, this lecture was a very high level lecture for mainly for the data architects. I've not gone into a lot of details, but hope it gives you some idea about how a migration, data migration needs to be executed. Okay, it's only about data migration, ingestion of data from your on-prem systems to cloud, that we have spoke about. But let me know in comments, if I should double click on any of these topics, and then we can get into more details. But this was just to give you a high level strategy of how do you migrate the data from your on-prem to cloud. And if you have liked this, please do follow me on Twitter and Medium, and do comment with your thoughts or any suggestions. And I'll be more than happy to discuss that. Thank you. Have a good day, guys.